Chapter 7. Soil. Quick Fiend Focus. Formation of soil. Soil profile. Type of soil. What does soil contain? Properties of soil. Soil and crops. The uppermost layer of the Earth's crust is called soil. Soil is a precious natural resource. Plants grow in soil. Plants absorb nutrients from soil and prepare their food in presence of sunlight. The food prepared by plants is used by all living organisms directly or indirectly. Soil is a home for many animals. Microorganisms like bacteria and fungi, animals like ants, mites, millipedes, beetles, worms, rodents etc. live in soil. Some of these are useful for the growth of plants. For example, earthworms turn and loosen the soil and help in decomposing dead and decaying matter. After death they turned into humus, which increases the fertility of soil. Soil keeps the plants in place by holding their roots firmly. Now let us study about the soil, composition, its formation types and properties in detail. Activity 1. To observe the presence of living things in the soil. Drain a small area in your garden with lots of water. You will observe small insects, larvae, earthworms coming out from the soil. This clearly shows that soil is a home to many living things. Formation of soil. Formation of soil is a very slow process. It is formed when big rocks break down into small pieces by the action of the sun's heat, wind, rain, flowing water and climatic conditions. The process of soil formation by the breaking down of rocks is called weathering of rocks. Weathering is of two types: physical and chemical. 1. Physical weathering. It is the natural process in which the rocks are broken down into smaller pieces without any change in the characteristics of the original rock. Temperature difference, growing roots of plants, frost etc. cause such a change. 2. Chemical weathering. In this type of weathering, the minerals present in rocks are broken down into new mineral components. This results in a change in the chemical nature of the rock. When weathering of rocks starts, the huge parent rocks break up near the surface, which can be physical or chemical. Then, the smaller rocks undergo weathering. Animal and plant remains in the soil are broken down by microorganisms to humus, which is the remains of dead and decaying plants and animals present in the soil. Lastly, minerals and salts seep into the ground along with water, making it favorable for better growth of plants. Constituents of soil. Soil containing of a number of components like soil particles, humus, microorganisms, air and water. Activity 2. To identify the various constituents of soil. Take a beaker and put a handful of soil in it. Fill the beaker up to 3/4 with water. Stir the mixture well and leave it undisturbed for a few hours. You will observe different layers on the basis of particle sizes. You can see large particles at the bottom of the beaker. They are called gravel. Above the gravel is sand and above sand is silt. Finally, at the top is the clay. The water above clay is not clear and has humus floating on it. Soil profile. A vertical section of the soil showing its different layers is called soil profile. Each layer of soil profile is called horizon. Soil profile can also be seen while digging a well or while laying the foundation of a building. Following are different layers of soil. 1. A horizon or topsoil. It is the uppermost layer of the soil which have following features. It is soft, porous and holds a lot of water. It is home to worms, insects, bacteria etc. It is dark in color due to pressure of humus in it. Humus make this soil fertile as it contains essential nutrients in it. The roots of small plants are trapped in this layer. 2. B horizon or subsoil. This layer of soil is just below the A horizon. It is harder than the top soil. It is rich in soluble minerals and iron oxide. It has a little humus and is light in color. The roots of trees generally reach to this level. 3. C horizon or parent rock. This layer lies below the subsoil. It is made up of lumps of rocks with spaces between them. Due to absence of humus, this layer is not fertile. 4. D horizon or bedrock. This layer of soil lies below the C horizon, which is made of hard solid rock. It is too hard to be dug with a spade. Rainwater accumulates above this layer and forms water table. Try these. Circle the correct word to make the sentences correct. 1. The A horizon, B horizon is called topsoil. 2. Below the C horizon, B horizon lies the bedrock. 3. Water accumulates over the C horizon, bedrock. 4. Soil formation is a slow, fast process. 5. In physical, chemical weathering, the minerals are broken down into new mineral components. Types of soils. On the basis of particle size, soil is classified into types. 1. Sand. 2. Clay. 3. Loamy as shown in the flow chart given below. Sandy soil. Sandy soil is formed by the disintegration and weathering of rocks such as limestone, granite, quartz and shale. It contains 70 to 80% of large sand particles and very small amounts of silt and clay particles. Due to large spaces between soil particles, this soil has poor water retention capacity and is well aerated. It lacks humus and hence is comparatively less fertile. It is not suitable to grow crops due to poor humus content and poor water holding capacity. Cacti and watermelons grow well in this soil. Clay soil. It is formed by the disintegration and weathering of rocks in a long time. It is also formed as sedimentary deposits due to weathering, erosion and transportation of rocks. It contains mainly clay and only a little amount of sand and silt. Its particles are very small, which leave very little space for air. It has high water retention capacity and is sticky when wet. It turns hard on drying. It also contains some humus. Some plants grow in this soil. Loamy soil. It is considered to be the perfect soil for growing crops. It contains equal amounts of sand, clay, silt. It is rich in humus and is dark brown in color. It has adequate air space and holds sufficient water. It is the best soil for growth of plants. Activity 3. To identify the soil that is best to make pottery. Take small quantities of sandy, clay and loamy soil each. Them separately adding some ball and water. Try to roll these soils into cylindrical shape and then try to make ring balls out of them. Kneading soil. Soil in cylindrical shape. Soil in ball and ring shape. You will notice that only clay soil could be turned into a ring. Therefore, this soil is used to make toys, pots and statues. What does soil contain? Together with humus and mineral salts, soil also contains the following things. 1. Soil contains air. Air is present between the soil particles which the earthworms and other animals living in the soil use for breathing. Let us perform an activity to observe the presence of air in soil. Activity 4. Take some dry garden soil in a glass. Add water to it. You will observe bubbles coming out of the soil. These bubbles confirm the presence of air. As water enters the spaces between soil particles, air escapes out. This air comes out in the form of bubbles. Soil contains air. 2. Soil contains water, or moisture. You may have noticed the air above the farmlands shimmering during the day in summers. This happens because the water present in the soil evaporates as water vapor. When sunlight passes through the water vapors, it gets reflected, causing air to shimmer. Let us perform an activity to show that moisture is present between the soil particles. Activity 5. To show the presence of water in soil. Take some garden soil in a glass jar. Cover the jar with a lid. Put the jar with soil over a flame. You will see tiny droplets of water on the inner side of the lid. This is because the water present in soil evaporates. The water vapor condenses to form droplets of water on coming in contact with the cold upper and inner surface of the glass jar. Properties of soil. The properties of soil mainly depend on the size of its particles. The properties of soil are as follows. 1. Soil allows water to percolate. Water poured over soil partially gets absorbed by the soil and the rest passes down through it and forms water table or underground water level. Such passing down of water into the soil is called percolation of water. The percolation rate of water in soil can also be defined as the volume of water in milliliter which passes down the soil per minute. It can be calculated by the formula given below. Percolation rate equals volume of water percolated in soil, in milliliter, by time taken for percolation, in minutes. The rate of percolation of water differs from soil to soil. The amount of water that seeps down into the soil has considerably decreased in towns and cities because of too many concrete structures. It is due to this reason that the water table has also gone down in some areas. Activity 6. To find the rate of percolation in different soils. Take 3 identical PVC pipes of length. Select 3 different places that have different types of soils, sandy, clay and loamy. Fix the 3 PVC pipes vertically at a depth of about 4 cm in those soils. Pour 500 ml of water in each pipe slowly. Note the time taken by the water in each pipe to seep into the ground. Calculate the rate of percolation of water for each soil separately, using the formula given. Percolation rate equals amount of water, milliliter, by percolation time, minutes. Compare the rate of percolation of all the 3 soils and relate it to the particle size. You will find rate of percolation higher in sandy soil. 2. Soil absorbs water. Soil absorbs water as it has spaces between its particles. Different types of soils absorb water to a different extent. Activity 7. Soils. Take 3 graduated cylinders. Place identical large glass funnel over each cylinder and fix a filter paper in each. Take 80 grams each of sandy, loamy and clay soil in separate funnel. Put these 3 weighed soils in the 3 different funnels having filter papers. Pour 100 milliliters of water in each funnel over the soil. You will observe that water drips from each funnel and gets collected in the graduated cylinders placed below. Leave the apparatus undisturbed till active dripping of water from the funnel stops. Check the volume of water collected in each graduated cylinder. You will find that maximum water is collected in the cylinder with the funnel containing sandy soil and the least is collected in the cylinder with the funnel containing clay soil. The percentage of water absorbed by each type of soil is calculated as percentage of water absorbed by each type of soil equals weight of water absorbed by the soil multiplied by 100% by weight of soil taken equals 150x by 80 multiplied by 100%. Here x is quantity of water in the cylinder. Try these. Answer these questions in short. 1. Which soil has poor water holding capacity? 2. What is percolation? 3. In which type of soil is the rate of percolation of water the highest? 4. Does soil contain air? 5. Which type of soil becomes sticky when wet and turns hard on drying? Soil and crops. Soil helps plants to grow. A number of crops are grown to fulfill the various needs of humans. Different crops require different types of soils to grow. For example, wheat and paddy grow well in clay soil as it has a good water retaining capacity. Cotton grows well in sandy or loamy soil. Lentils and gram grow well in loamy soil which drains water easily. Soils vary in color, texture and contents in different geographic locations. Soil erosion. The carrying away of the top fertile layer of soil by different agents like wind and water is called soil erosion. It occurs faster on barren land where there is little or no vegetation, such as in deserts. Factors responsible for soil erosion are floods. Flood water washes away the top soil and thus causes soil erosion. Forest fires. It burns the plant cover and exposed to soil to agents like wind and water which causes soil erosion. Deforestation. Cutting of trees in large numbers is the main cause of soil erosion. Overgrazing. Grazing of animals on the same piece of land here is also a reason of soil erosion. Soil erosion can be prevented or reduced by following ways. Construction of dams to control floods. Terrace farming. It is an effective way to minimize soil erosion in hilly areas. It is done by making steps on hill slopes. This reduces the speed of flowing water down the hill. By building bunds and embankments, soil erosion can be reduced. Afforestation. The best way to reduce or prevent the soil erosion is the planting of trees in large numbers. The roots of trees hold the soil together. Plants also act as barrier for fast-moving winds. They slow down speed of wind. Try these. Write true or false. 1. Forest fires help to prevent soil erosion. 2. Deforestation causes soil erosion. 3. Soil erosion occurs faster on barren land. 4. Lentils grow well in loamy soil. 5. Cotton grows well in clay soil. Quick recap. There are 3 types of soils, depending on the size of soil particles: sandy, clay and loamy. Different soils have different percolation rates. It is highest in sandy soil and least in clay soil. Absorption of water also varies from soil. It is maximum in clay soil and least in sandy soil. The carrying away of topsoil by the agents like wind, water etc. is called soil erosion. Soil is the topmost layer of the Earth's crust, and is a valuable natural resource. Soil is formed by weathering of rocks by agents like wind, water and temperature. Soil profile is the vertical section of soil showing its various layers. Soil contains soil particles, humus, air, water and living organisms.